Listen to this sound. That isn't radio static, and it isn't wind. It's a recording captured by Voyager 1 outside our solar system. We were told that out there, in the darkness, there was only a dead silence. We were wrong. Space isn't empty, it's screaming. And what Voyager just found in that darkness changes everything we thought we knew about our universe. Imagine absolute darkness. A silence so deep it begins to press against your mind. A cold that is inches away from absolute zero. This is the home of an object that is further from Earth than anything ever created by human hands. September 5th, 1977. The world was different then. People were listening to disco, the first Star Wars had just hit theaters, and we decided to challenge eternity. Cape Canaveral shook as the Titan rocket engines roared. Voyager 1 ascended into the sky. Its mission was simple. Fly past Jupiter and Saturn, take a few photos, and, essentially, disappear. Its expiration date was 5 years. But it's still there, almost half a century has passed. It runs on technology weaker than your car's key fob. Its transmitter has the power of a light bulb in your refrigerator, and yet, we still hear its whisper. But recently, that whisper changed. Voyager crossed an invisible line. The boundary where our sun's influence ends and something else begins. NASA scientists expected a void, a quiet, still dead space. Instead, Voyager sent back data that made astrophysicists turn pale. Out there, in the dark, there is something. And it is much wilder than we ever imagined. To understand what Voyager found, we need to understand what the solar system actually is. We think of it as planets circling a star, but that's only half the story. The solar system is a giant bubble. Our sun isn't just a lamp, it's a nuclear reactor constantly spitting out millions of tons of superheated plasma. We call this the solar wind. This wind blows a massive sphere around us called the heliosphere. It protects us. It deflects deadly radiation from deep space. We live inside this cozy bubble, but every bubble has an edge. The place where the solar wind weakens and hits what lies outside. The interstellar medium. This place is called the heliopause. The border, the final outpost. For years, scientists debated what this transition would look like. Would it be smooth, like walking out of a fog, or a sharp wall? Voyager 1 gave us the answer when its sensors suddenly spiked. The wind from the sun vanished. The temperature shifted. Radiation levels soared. The probe was out. It became the first man-made object to enter interstellar space. And that's when the real mystery began. Instead of falling into a vacuum, Voyager was hit by a rain of energy. The instruments showed that the space outside our system isn't empty. It's thick. Let's stop for a moment. What does thick space mean? In school, we are taught that space is a vacuum, emptiness. But emptiness is a relative term. Inside our system, space is filled with thin solar wind. But outside, there is cold gas, dust, and plasma from the explosions of thousands of stars that died millions of years ago. As Voyager crossed the border, its plasma wave instruments began to pick up strange vibrations. At first, they were short bursts. Engineers thought it was a hardware glitch. The probe is old, its memory is corrupted. But then, these bursts became constant. Imagine standing on the shore of an ocean during a storm. You hear the roar of the waves. That is what Voyager heard. It recorded a persistent rhythmic hum. NASA released these recordings. If you shift them into the human hearing range, it sounds like an eerie, low-frequency whistle. This is the sound of interstellar space, but the wildest part is what the analysis revealed. The density of matter out there, beyond our bubble, is much higher than we predicted. The plasma is compressed. It vibrates. This means our solar system isn't moving through a void. It's plowing through a dense cloud of interstellar matter, like a submarine moving through heavy water. And the pressure, it's colossal. Scientists found that the external pressure is so strong it actually holds our sun back. If it wasn't for this outside force, our heliosphere would be much larger. We are locked in this bubble by a force we are only beginning to understand. But the discovery of dense space was just the beginning. Voyager recently transmitted data about something we can only call a tsunami. Imagine a wave of shock energy that started at our sun. A solar flare. It flew past Earth, Mars, and Jupiter. We had already forgotten about it, but years later, that wave caught up with Voyager far beyond the system's edge. And what happened? This wave slammed into the dense interstellar plasma, and the plasma rang like a bell. Because of this ringing, scientists were able to measure the density of the environment exactly. It turns out Voyager is currently flying through a zone where matter is 40 times denser than it was inside the solar system. This shatters our view of the galaxy. We thought stars were lonely islands in an ocean of nothingness. But now we see that the ocean is alive. It's full of turbulence. There are currents. There are storms. Voyager is currently in the middle of that storm. And here a disturbing question arises. If the space between stars is so saturated and active, how does it affect our journey through the galaxy? We know the solar system orbits the center of the Milky Way. What happens if we fly into an even denser cloud? Could this external pressure compress our heliosphere so much that it affects life on Earth? Some theories suggest Earth has passed through such clouds before, potentially triggering ice ages. Voyager is now our eyes, looking into the future of our path. But Voyager's time is running out. It is powered by a radioisotope thermoelectric generator. Essentially, a lump of decaying plutonium that generates heat. That heat becomes electricity. But the plutonium is cooling down. Every year, Voyager loses about 4 watts of power. NASA engineers have already begun shutting down systems one by one. First the cameras, then the heaters. The probe is now operating at temperatures that should have killed it, but it holds on. Scientists say that by 2030, the energy will be so low that Voyager won't be able to keep its antenna pointed at Earth. In that moment, the link will break. We will never hear its signal again. It will become just another stone in the cosmic sea. Or will it? On board Voyager, there is something else. Something that doesn't need power. The Golden Record. A 12-inch gold-plated copper disc. It contains the sounds of Earth. Greetings in 55 languages. The sound of rain. A mother's heartbeat. Laughter. The music of Bach, Mozart, and Chuck Berry. And photos. Our faces. Our DNA. Our cities. When Voyager goes silent, it will stop being a scientific instrument. It will become an ambassador. It will sail through this dense, vibrating plasma for billions of years. Stars will be born and die. Our sun will one day become a red giant and swallow the Earth, but Voyager will still be there. Intact, it will carry the memory of us into eternity. What Voyager found beyond the border, this dense, noisy, energetic ocean, changes our reality. We can no longer look at the night sky and see only blackness. Now we know that the space between stars is filled with matter, sounds, and the history of the galaxy. Every bit of data coming from 15 billion miles away is priceless. The signal takes over 22 hours to reach us. Think about that. Light itself needs nearly a day to travel from the probe to us. It is the longest phone call in history, and it is coming to an end. But while Voyager speaks, we must listen. It tells us that the universe is much more complex, wilder, and louder than we thought. It reminds us of our own courage, that a tiny civilization on the 3rd planet from the sun had the audacity to throw a piece of metal into the abyss, just to see what was there, and found the music of the stars. Thank you, Voyager. Safe travels.